All right, so I'm going to ask you to go to page 9 real quick. Page 9. And remember, we're still classifying triangles. It's not going away, so classify each triangle based on angles and the sides, okay? That is always what we're going to do. When it comes to angles, you have 3 options. You've got acute, right, or obtuse. Sorry, it's this is on page 9. When it comes to sides, you have equilateral, isosceles, and scalene. And yes, there's a relationship. Sometimes the angles will tell you something about the side length, so always keep that in mind. I will not do all of them because I posted this online, but I will walk you through some of these. Okay. So let's look at question 1 for instance. Okay. I want you to see that the sides here have those markings. Okay. That immediately tells us that those angles across those sides are also congruent. Okay, so this angle right here is going to be congruent to this one here. It's going to be the same. Okay, so we know this triangle is obtuse when it comes to angles because it's bigger than 90. But we need to figure out this is what I'm going to tell you. If you can find more information, do it. Okay, do it. So can we find these angles? Absolutely. We can go 180 minus 115, right? We're going to take the 115 away from 180 and the remainder will be split in half. Because we know that these two are the same, given that the sides across from them are the same. Okay, so you go 180 minus 115, that's 65, okay? 65 divided by 2 is 32.5. Now in this particular case, it doesn't make a whole lot of difference, but we know that this is 32.5 and this is 32.5 here. They're both 32.5. So when it comes to angles, this is definitely an obtuse triangle. When it comes to sides, because of these two markings, it's an isosceles. Just like that. Okay. So you would get normally 1 mark for each name. Okay. Obtuse isosceles. When there are no numbers, okay, no numbers given, then just go by diagram. Okay, you're just gonna have to make assumptions based on what it looks like. And right here, that's definitely an obtuse greater than 90, greater than 90 degrees. Because remember, 90 would be right here. This would be a 90. This is bigger than 90, right? So this would be an obtuse when it comes to angles. And what about side lengths? The markings are all different. So that is a scalene. Scalene. Okay, when the markings are all different, we know that it's a scalene triangle. Which other one should I go with here? I'm just gonna leave it. Maybe I'll do this one because this one is trickier. Go to 3 real quick. I want to bring something to your attention because sometimes students miss this. These two sides are the same, so we're definitely looking at an isosceles triangle. So what you want to do is you're going to be like, oh, if this is 45 here across this side, and this side is the same as that one, it stands to reason that this angle will also be the same. This will also be 45 degrees. Okay, because if the sides are equal and so are the angles across from them. Okay, if this is 45 and this is 45, what's this going to be? Going to be 90, right? Because you go 180 minus 45 minus 45, that is 90 already, right? So we end up with 90 degrees, which is that angle right there. So in this case, finding some more values allows us to actually narrow down that this is not just perhaps an acute triangle, this is actually a right triangle. So we would say right in terms of angles and isosceles when it comes to the sides. Okay, a right isosceles triangle. Okay, so you can continue this. Maybe I'll do one more because tomorrow I would start seeing you on this. So let's look at 4 here real quick. I want you to observe that these two sides are the same. Okay, so in a sense, if those measurements hadn't been there, we would have had markings like that. That means that both angles across them, right, are also congruent. This one is going to be the same as this one. Okay, because these sides are the same, so are the angles across from them. That's always going to be true in life, guys. Just make any triangle. If you have two sides that are the same, the angles across from them are going to be the same. So we can find this out because if they're the same, we're just going to go like this, 180 minus the 70. And whatever is left, we're going to split it in half. Okay, so that's 110 divided by 2. That is 55 degrees. So you found that this is 55 and this is 55. Okay. And now you know for sure when it comes to angles, this is an acute triangle because they're all less than 90. And when it comes to side lengths, well, of course, these two are the same, so it's an isosceles. And you're probably wondering, I don't know, maybe you're not wondering, you're like, what about this side, Mr. Dirksen? We don't know what that is. That's true, but we do know that the angle across from it is 70. So this side will be longer than either one of these. We know that for sure. We don't need to go ahead and solve it because we are able to conclude the name. We are able to classify without it in this case. Just kind of, we're extrapolating basically. Okay, so I'm going to leave it there. And there are more you can practice, and the answer keys are posted. So now I'm going to introduce you to go to page 11 real quick here. And I don't know if you did this, but I'm going to do a 1 or 2, and then before we move on, I want you to sketch because it takes seconds to sketch, and you get marks for it. So go to page 11. If you're watching this, you can pause already and try it first, right? Sketch the following. You may use markings or actual measurements for this. Okay. So let's say this is going backwards, right? I want you to sketch a triangle that is acute and is scalene, right? What does this mean? All angles less than 90 degrees. That's what that is telling us. And scalene is telling us that all sides are different. You know what? I can also say in brackets angles. I can make either all angles different or all sides different. Either one of them will make it happen for us. So this is what I ask you to do. Just sketch it like this. Something like that. And you can make this 80. You can make this 50. What are we at already? 80 and 50 is 130. So this would have to be 50 as well, right? We have a problem because now you have an isosceles triangle, correct? So you have to go back to the drawing board and say, well, I'm going to make this 60. Okay? 80 and 60 is 140, which means that this will be 40 degrees. And now you have yourselves, this right there would actually be a scalene acute triangle. Because if all three angles are different, we know all three sides will be different as well. But you could have done this if you wanted to. right? Just to emphasize the point, but that would do the trick there. Okay. Next, obtuse. Obtuse tells you that there's one angle larger than 90, and isosceles is two sides or angles are congruent, right? That's the symbol for congruency. They're the same. Okay, so how you do that one? I would just make the tip very big like that. And then I will make sure I put in an angle that's bigger than 90. I will say 100. Okay, and I will make these two sides the same. You can use markings or you can use measurements. You can say, hey, this is 20 inches and this is 20 inches. And that does the trick. Okay. So just so you know, if this is 100, then there's 80 left. So 80 divided by 2 would be 40 and 40, right? These two would be 40 each. I don't go that far because I don't have to. This is already good enough, okay? I'm going to stop here. I'm going to ask you to try the other 4 before I move on. It shouldn't take you that long. See if you're able to do that. Easy marks if you've done it. Anybody already done this? This page is already done? It's already done? Okay, so everybody else just take, so you make it work. I have a triangle that is supposed to be obtuse and scalene. So watch this. If you go off of the acute scalene, I'm kind of going to copy this and just make the top a little bit bigger. Maybe like this. But you want to make all 3 sides look a little different in length. So you could put, you know, 95 up here. You got to be careful, right? This would be the smallest angle here. So you could give this one 65, right? That would be 160. That's already 160 there. And then, so that would be 20 degrees here. And you made that 95, so it all adds up to 180. That's something that I would definitely be looking for. And then you just go ahead and make all 3 sides different in length. To be honest, the markings would also be optional here, because if you're showing me that all 3 angles are different, you are telling me that all 3 sides are different in length as well. So as long as it's not contradicting, so if you add more, make sure it doesn't contradict what you already have. A right isosceles, I'll show you how I like to do my right isosceles. I usually have them like this, where I have a 90 at the top, and then I just do this. That technically would be a right isosceles, but it doesn't matter. If you wanted to do it this way, put the 90 there. Just make sure that, right, these 2 sides are the same. Okay, it shouldn't be the one across the 90 because that's the longest side. You can't have another one like the hypotenuse, right, in this case. So you do have to be a bit careful with that. Acute isosceles, there I would just do something like this, like it's probably a little steeper. I'd make these 2 the same. And something that you could try is, like, if you make this 50 and this 50, that's 100 already. That would make the top 80. Use easy numbers, right? So you're clearly telling me that no angle in there is greater than 90, or even exactly equal to 90, and 2 sides are the same. Equilateral, so something like this. Dun, dun, dun. And it doesn't hurt just to say it's always going to be 60. It doesn't matter how big or small the triangle, it's always going to be 60 all around. Okay. Always. All right, let's go on to the harder ones. These ones require a little bit more work. So we'll dive a little deeper. Nothing that you can't handle. I'm just going to show you that you have to do some calculating. If at all possible, just do some calculating if I give you numbers. So let's go to page 12. So I will say at the top where some work is required. How about we just write down harder? They're a little bit harder. They're a little bit more work. This is on page 12, and let's go and get this done. Okay. Okay. So you have a triangle here, but there's some angles outside of it. You remember supplementary angles, right? There's a straight line here. So this side that cuts into it, right, will split this straight angle of 180 into two. So if this is 120, then this is 60, right? Like this one and this one, they add up to 180 degrees there at that intersection. So now you have this angle inside there. Okay. Moving on, you look at this one here. There's a straight angle right there. If this is 150, then this is 30. Yes. Thank you. Thank you. So you're slowly inserting angles into that triangle you're trying to classify. If this is 60 and that's 30, that's already 90. That means that this one would be 90 as well. But I'm going to show my work here, okay? See, right now you're like, yeah, I know it's 90, but I think I always need you to know, right? This doesn't look like a 90, but don't worry about that, right? But there's a 90 there. There's technically a box here. So this would be a right triangle in terms of angle, and in terms of side length, this would be a scalene. But Mr. Dirksen, there are no side lengths. Yes, but I'm looking at the angles, and I can guarantee you they're all going to be different in length based on the angles, all right? So that's as much work as you could do here. If you have no side lengths, you cannot find it at all. There's no way to do it. You have to go by the angles themselves. Another one here. I'm going to make an observation. I have a 41 and a 90 there. I can easily find this angle here. Why don't we do that? It's not that hard. 180 minus 90 minus 41. That would be mental math Tuesday. 49, correct? So this is 49. I just did it because it doesn't hurt. But I already know in terms of angles, I was kind of seeing like, could this be an isosceles? But no. There's a 90 here, so this would be a right for sure. And then the other name, I have to figure that out. Based on these two angles, right, there's no way that this is an isosceles. And in fact, if you look at all three, they're all different in measure. So this is a scalene as well. Since all angles, can I do this? They're not congruent. Okay, so I'm going to stop writing as much. I'm just going to say, since all angles are not congruent. Is it possible, Mr. Jackson, would it be possible to find more sides? Yes, because you actually have a pair. Remember sine law? You have a pair. You have this angle, you can find that side, but it's not necessary. In this case, it would be too much work. If you know all angles, you already have enough information. One more. How about this one? You only have the 90, so you know this is going to be a right triangle for sure. I think we can confidently say right. But now we have to find out a little bit more because we don't have angles, so we can't make any further assumptions about their side lengths. Like this could possibly be an isosceles, we don't know. So what do we do if we have a right triangle with two sides given? We did this yesterday. Pythagorean theorem. right? So this is my hypotenuse, leg, leg. So I'm going to find this leg down here. And the way you do that is leg is equal to square root of hypotenuse squared minus the other leg squared. Let's figure out what that is. 3.9 squared minus 2.8 squared. That's 7.37. 7.37 inside the root. I'm going to take the root of that, and that is 2.71. What are we at, meters? I'm going to move this up a little bit on you here. But they're all different. You might say, oh, they're close, but it's not close enough for us, right? So this is 2.71 meters. So all sides are different, therefore it's scalene. You had to do some investigating to know for sure. If you had all three angles, this step would not have been necessary for you to conclude that it's a scalene. So I hope you're starting to see the connections between having all angles and not needing to find the sides, right? And just as you thought, it's not going to get harder. It's going to get a little harder. So this is like intermediate. So we did easy, intermediate, and now we're going to do the harder ones. So come with me to page 13. I'm probably going to be done fairly quickly. Okay, let's go to 13. We'll end there. And then I'll ask you to do some on your own. Using sine law and cosine law to classify triangles. At times, there will not be enough information given to classify the triangle. You must use all the tools. Let's highlight that part. You must use all the tools you have learned about them to find out more. Okay. So classify the following triangles. This is an SSS case. Okay. SSS case. Fun stuff, eh? In terms of the side lengths, what can we conclude? Because we have all three sides. So let's give it a first and a last name. In terms of side length, we know this is scalene, correct? I tend to do that as the last name of the triangle, right? I will say this, all sides are not congruent. That's how I came up with the scalene part. But because I give you enough information, you might say, hey, this looks like an obtuse. I know it's an obtuse, Mr. Dirksen. If I give you enough information, you must find out for sure, okay? So where are we going to focus our attention? Not this, not this. We're going to focus on this one here, okay? I'm going to put a big question mark here. Like, what is this one here? Is it possibly obtuse? Is it obtuse? Question mark. Right? That's our question. Like the other ones don't really matter to us because if this is obtuse, we know the whole triangle is called an obtuse triangle. If that angle is bigger than 90, we're done. Okay. So do you remember how to do that? Side, 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 right? Cosine of y, make sure you write this down. What's the first side? There's going to be two sides adding and one subtracting for sure. We always take, if you look up here, you take the side across the angle you're trying to find and you slap it at the end, square it and subtract it, right? And then the other two sides, we square and add. And at the bottom, it's 2 times the first side times the second side. Just like that. How are we going to know whether or not this is obtuse without even solving the whole thing? Anybody remember? There is a way to find out fairly soon. If you do the top, I'm just doing the top here and I hit equals, what do I get? I get not just any number, I get a negative number. Okay, so I'm going to go like this, negative 0.95 over 2 times 4.9 times 3.5. That's 34.3. I'm going to highlight this. Because of this, you can actually stop and say, this is obtuse. This triangle will be obtuse without me even solving any further. But I will still finish this, this part here because I want to make sure we get this right. So to find out the answer for sure, we go angle y is cosine inverse of whatever I get when I divide this. And I will do so right now. Negative 0.95 divided by 34.3. That's negative 0.026 and so forth. And I'm going to go shift cosine, hit equals, and that's 9159. So just as a refresher, that's how you do it. But we could have already concluded that right here without going through the trouble of actually finding the final answer. Okay, so that's how the harder ones are done. I'm going to ask you to continue for today. I will probably pick this up tomorrow and do a few more. But just go 13 all the way to 16. So I'll say this, page 13 all the way 16. My answer key will probably have more questions than that. And there it is. Okay. I think that my key does not include this one here at the bottom of 13. So if you're watching this, or you might want to pause this, I'm just going to make it appear so that it's on record. I don't know if you guys want to take a picture if you're in class. But in this case, I used sine law for this one. But I encourage you to do it yourselves yet. So the problem is, I'm just going to say one more time, the problem is that you're only given one angle or maybe no angle whatsoever. Then you need to do a little bit more digging. You need to use sine law or cosine law. I'll say it one more time. You only have one angle or no angle at all, like at the very beginning, the cosine law question. Then you need to do a little bit more digging. Okay, that's what makes these a little harder. So that's it for today, guys. Thank you.